Hey everybody, this is Larry. This is week 1 of the April Leetcode challenge, something like this. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Today, Web 317, shortest distance from all buildings, is a hard problem. We're given a grid, we have R times C. I always convert it to R times C because M times N just sometimes it's confusing them. Sometimes it's M times N, sometimes it's N times M, who knows. Anyway, you have a two-dimensional grid of 0, 1, 2, where 0 is an empty land, 1 is a building, 2 is an obstacle. What's the difference between a building and an obstacle? You both cannot. Okay, you want to build a house? Okay, maybe there's more. You want to build a house on an empty land that reaches all the building in the shortest total travel distance. You can only move up, down, left, and right. Return the shortest travel distance for each house, for such a house. If it's not possible to build such a house according to above rules, return -1. The total travel distance is the sum of the distances between the houses, right? Okay, so we okay. So what does the obstacle mean? The total sum of the distances between the house and the meeting point. I'm kind of confused with this problem, honestly, a little bit. Mostly because maybe I'll read the example. Mostly because I don't get what if the distance is just the sum of the distance between the shortest travel distance, you're gonna move up and down. But like, what does that have to do with Manhattan distance? Like it's the two things, right? There are two things. There's one is that the distance is the Manhattan distance, which is fine, and then the shortest travel distance, which is also fine, right? But which one do we use? They're not the same, and like I don't get it. Like, okay, I guess maybe this one will maybe illustrate a little bit more because the 1 to the 1 maybe. All right, let's see. Given 3 buildings and obstacle 0, 2. I mean, okay, we cannot build on an obstacle, I think. It actually doesn't even mention that. No, it's on an empty land. So, okay, so you cannot build on top of a building and you cannot build on an empty land. Okay, that's fine, right? But what is the shortest travel distance thing? It is way weird. Alright, let's see. And so given 3 buildings, you could put it on 0, 2. An obstacle on 0, 2. 1, 2. So, okay, so that's not really useful because it doesn't tell me anything about, like, what is the, like, if it's the travel distance, it's the travel distance. If it's a Manhattan distance, it's a Manhattan distance. They're two different things. I don't get it. Like, I don't get what the, like, and none of this is helpful, to be frank. This is a very weird problem. I would say, yeah, I don't, it's not even a weird problem. I think it's just a poorly specified problem because these two things are like different, right? Yeah. Anyway, okay, fine. Like, okay, so we can't build on a building, we can't build on an obstacle, but still, like, travel distance? This is I don't get the Manhattan distance or travel. Okay, but anyway, we could solve it for both, I think, at least logically, and then we can guess which one is the one that they want, because this is just mind reading at a certain point, and there's no way for me to know. Okay, so if it's Manhattan distance, then the thing is that it's going to be this idea of median that comes into play again from time to time. But the idea here is that if you have a median, then it would be ideal, right? Just because here, then now you could compress it to one dimension on X and then the Y, and then you can solve them independently. But once you do, then you just realize that by the exchange argument you can go left and right. But the only thing that is a little bit trickier is that you cannot build on like the median, right? Always, because there's an obstacle that there may be a building there, there might be an obstacle there, so we may not always be able to build there. So that might not be the answer. The other one is just the shortest travel distance, which is fine. So it's just, you would maybe do, for each point, you would do a breadth first search. That said, it is 50 times 50, so 50 times 50, which means that it's going to be 50 to the fourth, which is like what? 2,500 square, so that's 6.2 million. I guess that's probably fine. Maybe. I don't know. Leetcode sometimes have weird constraints. I don't know if that's actually fine. But if you do a breadth first search, that's fine, I think, from every cell possible. So let's do that, I think. And then if it's wrong, then we'll try to figure out how we're wrong. But honestly, having this farm is just a little bit crappy for being a little ill-specified. But yeah. Okay. Yeah, okay. And then now maybe we just go right? Yeah, okay. I mean, I'm still trying to figure out like how yeah, how this farm is just annoying. Yeah. Right, and then we have, yeah, and then we just try to solve for it, right? So maybe we have a, was it minimum? So okay, so we have some infinity, and then we just return best, right? Right. All right. Let me run it real quick. I'm a little bit rusty on the types. Okay, fine. Yeah. Okay. So then now we want to say south is, oops, min. Yeah. Okay. Right. And then maybe we can write, yeah, I think that's fine. I don't know if this is the right syntax anymore. It's been right. The good thing is that it is what do we call it? So here we are. Right, so here maybe we have Q. Alright, is it a pen? A push, I think. Okay. Oh yeah. X. Let's go to SXSY for the starting X, starting Y, and then you have right. Oh yeah, shift is what I was thinking. Oh yeah, maybe that's what I want. Total is equal to total score, and we're always able to, if it's not able to construct, return -1, so then maybe we would return infinity in that case. Okay, we have to add some logic here. Okay, so maybe we have something like, right, then we return -1, because if you could build one house where it's not all connected, that means the entire graph isn't connected anyway. That's what I meant to do there, right? What else am I doing? Yeah, okay, what else am I doing? Oh yeah, just usual. Too used to certain syntax. Something like that, right? Yeah. I think it's undefined when I guess I didn't define it, but yeah, whatever, let's keep it. Do I need to use 3 of these here? Maybe I do. I don't know enough. Okay. I also have to check that grid of nx and y is equal to 0. Right? I have to check it here as well. I actually forgot. Right, and then now we can, yeah. Yeah, no, that's the right syntax. Right. We also forgot to do this, and we also forgot to create a way. Oh, yeah, the total will save later. Building, it's very confusing, this problem. Because if you're coming out of a building, that's fine, but you cannot get by a building, is that right? This problem is like, I mean, it's fine, it's just that they don't tell you stuff and I have to guess stuff. So I'm gonna be surprised if I'm just wrong a lot because well, they don't tell you anything. This is fine, right? I don't know. This is so weird setup because we should set the distance, but and it is lightning. We gotta write this. I don't know. I don't know what this farm wants. This is a pretty poor problem, so I don't know. So we do this, but we don't enqueue maybe, and then now we can go to Okay, and just return total. Nine. I mean, it may be that I don't know what the right answer should be, but 9 is worse than the right answer, so that's not good, right? Because if my interpretation is wrong, I should at least, or in the worst case, get, oh yeah, I forget to. Wait, did I not do this? Why is it returning infinity or some big number? If it's right? Oh, you just can't build anywhere, I guess. Okay, fine. But that's a crappy, like it doesn't help me as a test case. Here, okay, why would I get 9? Just can't. I don't remember the syntax. This right, so 1 2 is 9. Why is 1 2 9? 1 1 2 3 1 2 3 is 7, right? That's weird. Has to be 0. Okay, that's fine. Restart. Oh, I see. This has to be min. Oh, I mean, either min or that has to be infinity. Because I keep on updating it. I think that's why. Yep, okay. Let's see if this is... I mean, the inputs are not good enough for me to tell that this is wrong, right? Because, yeah, okay, well, maybe this is wrong anyway, because I returned -1 when it shouldn't have. So that's wrong. That in either interpretations, that should not be the case, but it is what it is. That is weird. So let's see. I don't get. Okay, wait. Let me draw this out. Maybe I don't. I see. I think I see why, but I think it's just because I don't understand this problem. But I have to also double check, right? So let's visualize this a little bit. I guess I was wrong on the early termination, because it was probably trying this 0, and I just it doesn't reach all the cells. So, but there is cells in the middle that could do it. So I was wrong on this this thing. So I think we can just remove it and it'll be fine. It'll be. I only did it because I thought it would be faster, but and it would be faster. It's just that it might not be right. But if I time out, at least we know that our interpretation is right. But okay. I mean, this is a really weird problem. I mean, I don't think it's that hard, but they could have just given us one example to kind of clarify everything. And also, just to be clear, right? Like, there's nothing about Manhattan distance here. So that's why I think that threw me off more than anything, is that the Manhattan distance thing. But yeah, that's pretty much it. This is basically, yeah, for every cell, every buildable cell, you go BFS. I didn't miss a case where... Some of it is because I didn't really fully believe my interpretation of this problem, right? Because I wasn't sure like how to interpret this. So I was just like, let me just try something, and it's fine to get a wrong answer, but because I don't know if I'm gonna like why would you consider edge cases if you're not doing even the right problem, right? So like if I'm going to do the wrong problem, then I don't want to waste time considering all the edge cases. So that's kind of why, which kind of made this crappy kind of thing, because it's not that bad, but yeah, it wasn't that super interesting. But yeah, this is going to be n squared, where n is not the input n. N is the number of cells, which is r times c. And this is just buffer search from every cell, right? So pretty straightforward. I wonder if there's a better solution. So let me take a look at the editorial. Maybe there's something that I could take advantage of, but Yeah, I don't get why they. I know there are obstacle between points, which is why you don't do Manhattan distance. You silly goose. Okay, so they just basically say the same thing, right? Oh, space complexity of ours is also O of n, which is the number of cells. Yeah, okay, I mean, this is the same thing, right? Just going the other way. And you have to store more things, maybe. How is this to empty land? No, this is still the same thing as well. I don't know. Oh, yeah. The number one comma is the same thing. Yeah, so... Leetcode. Thanks, Joe Wang. Yeah, it's just confusing. Just confusing. I don't know. And the thing is that, like, I got wrong answer, but that's because I probably could have figured out that edge case, but I wasn't thinking about those edge cases because I wasn't sure that what my interpretation is right and how to handle all these things. But they could have just also solved it with one example, right? And I did know that you couldn't pass through buildings, but I don't know. Anyway, that is all I have for this one. Let me know what you think. It's a very silly one, I think. Not difficult, just silly in the way that, you know, like it's not a good problem statement. But yeah, let me show you the code one more time. This is going to be the solve function, which is just a regular BFS, along with kind of get the distance for the fails. Here, I just do a loop through all of them, and that's straightforward, I hope. But yeah, that's all I have for this one. Let me know what you think about this. Thanks for watching. Stay good, stay healthy, do good mental health. Let's have a good month, everybody. I'll see y'all later and take care. Bye-bye.